So this is a modern semiconductor solid state diode bridge rectifier, and these are readily available. This one costs probably $5 or $6. It's rated for 200 volts, 50 amps, which is plenty of capacity for anything you'll probably be working on. And it's basically an encapsulated device with essentially 4 diodes in it, and it's got 4 terminals. There's a code on the back here, a diagram that shows you how the terminals are to be connected. You get 2 AC inputs, a plus and a minus output, and it's basically oriented this way, which I've gone ahead and labeled these things on the other side just to make it easier. Got the 2 AC inputs and the DC plus and minus output. For most of these machines that use DC, plus or minus are interchangeable. It doesn't matter which output you call minus and which one you call plus, because they're basically, you can swap them, and as long as you're consistent throughout the machine, which the machine wiring itself is, it doesn't matter. So I've gone ahead and actually wired one in here. You've got the, again, the 110 AC coming in to the transformer. You've got the 20 volt AC coming out. And I have gone ahead and put the two output windings in parallel to get more power, which is what I believe was their intent for having 2 windings coming out with the same voltage. Either that or it's the only transformer they could get, and that would give enough power. So anyway, the 2, one lead from each winding wired together, going to the AC input, one of the inputs on the bridge, the other 2 output leads, one from each winding wired together, going to the other AC input. You got to be careful when you're putting wiring transformers in parallel. If you get the wires swapped, will essentially be fighting each other. One of them probably will get real hot, if not both of them, and you'll have a big problem. There are ways to verify before you do this that you're doing it right, but I won't get into that because most of the time you're not going to see this. You will see just the 2 output leads for the higher voltage. You also see these 2 leads coming out, and that's the 6 volt AC, goes directly to the light terminals. That's not rectified. Lights don't care if it's AC or DC. So anyway, this is wired in and ready to be, these wires right here are connected to the terminals on the outside of the device, and it's ready to be connected to the machine. But first we're going to check the voltages. So I've got the basically the output terminals plus and minus connected to my meter right here. Meter set on DC. It's reading a little residual voltage, but that's just error in the meter or the circuit. I'm going to go ahead and turn on the power. And you can see it's reading 18 volts DC. So you get 18 volts DC coming out of this thing. We had about 20 AC going in. There is some internal resistance in the winding, not the winding, sorry, well, yes, in the windings of the transformer, and in the diodes have a voltage drop themselves, so it's going to drop it down a little bit. And so if you remember, this was rated for 12 volts, so we have 18 coming out. However, when we hook a load up to this, right now there's no load on it. There's nothing connected except a meter, which draws virtually 0 current. That will pull the voltage down somewhat, and we're just going to have to see what happens as far as what we get as an output voltage. Another thing with the selenium rectifiers, their internal voltage drop was typically several volts, as opposed to a diode, which is I believe less than a volt. So they they increased the voltage going in, so that when it dropped going through the selenium rectifier, it would be down to the operating voltage that was needed. So I'm going to connect just a dummy load up to this, some resistors, and see what happens to the voltage. I've connected some resistors to this, just wired to the output, plus and minus. It's measuring about 3 ohms. These are power resistors. These are 10 ohm, 10 watts. You've got 4 of them. When you put resistors in parallel, the resistance drops. I tried to get it as low as I could with the parts that I had, and in reality, when you connect this to a machine, the resistance that you're going to see, if you just measured it, is going to be very low. Probably with the old pre-war or DC, 12 volt DC, 6 volt DC machines, the ohmage that you're going to see as a load on the machine is going to be probably less than an ohm, actually. And that's because the machine has a lot of coils and resistors. Coils are resistors, essentially, in parallel, and that is going to basically drop the overall resistance. Anyway, I'm just going to try it with this and see what happens. I've got the meter. I'm going to put it on DC. I'm going to turn the power on, and I'm going to see what kind of voltage we get. And we get nothing because I have not connected this lead. Let me do that. There we go. Okay, give it another shot. Okay, and we're getting about 12 volts. What do you know? Now these resistors are going to get very hot very quick, so I can feel it. It's getting hot. I'm going to turn it off, and that's because they don't have the power rating. 10 watts is not nearly enough for the current that's going through there. But it does illustrate that when you put a load on this, the voltage will drop, and it will drop to somewhere near, hopefully, the operating voltage that you need. If it goes a little lower, typically that's no big deal. These machines are very forgiving. If you've got, if it's a 12 volt machine, you have 10 to 14 volts, say, it'll be fine. If you're connecting it up to the machine, and you should read the voltage that you're getting, and if it's too high, you can put a power resistor in series with the power supply coming out, and that would essentially take the place of the internal resistance that was in the selenium rectifiers that you're not using anymore. And one way to do that is to get a low resistance, high wattage potentiometer or rheostat, and that's what this is. This one actually came off a back control for a baseball machine. You can get these new ones for about 15 bucks on Amazon. This one is it's about a 20 ohm, probably 25 watt power capacity device, and you would want something in that range. And then you can just dial in with your meter on the power, dial it in until you get 12 volts with the machine operating. So that's the key, is you have to check it while the machine is operating with most of the motors and or coils that would be on, just to see what the voltage is. Chances are you won't need this, but it's just something to keep in mind.